In this video, we're going to express in Riemann summation as sigma notation with the function f of x equals x plus 2 squared of x equals from x equals 1 to x equals 5 with n equals to 12 subintervals. So it's the approximation of the area under the curve between these two for this graph with 12 subintervals. And this one is f of x equals 100 over x plus 10 from x equals 0 to x equals 3 with 6 subintervals. Actually, the problem was approximation of the area under the curve from the right Riemann sum for this and left Riemann sum for this, but actually let's do both and compare them. And actually, if it's not too hairy, maybe we can calculate the midpoint. Alright, so if you think you can do it, stop the video now and next continue to see if we have the same result. Alright, so the right Riemann sum for this, remember, is sigma notation from I equals 1 to n of f of x sub I delta x. This is the same as sigma notation from I equals 1 to n of f of a plus I delta x times delta x. This is one way. The other was sigma notation from I equals 0 to n of f of x sub I plus 1 delta x. This is sigma notation. Here I equals 0 to n minus 1 of f of a plus delta x times I plus 1 delta x. Alright, this is for the right Riemann sum. Alright, so first, remember these steps are: first, find delta x, next, x sub I, next, f of x sub I, and fourth, you put the sigma notation. More or less. So first, what's delta x? We have the graph f of x equal to x plus 2 squared, so it's something like this. We are estimating the area under the curve from x equals 1 to x equals 5. To x equals 5. Whatever, let's put it here. So the width of the sum of the widths of all the rectangles are from x equals 1 to 5 is 4. Is delta x will be 5 minus 1 divided by how many rectangles we have? 12. So the width of each rectangle is 4 divided by 12 is 1/3. Alright, now you can do it. I think the easiest way is we know we have already know how to express this sigma notation, and so we continue to this. The easiest way is with this one. So what's x of I? Here this is x sub I, this is x sub I. X sub I is a. A is, we are beginning, we have the graph and it's from A to B. A is 1. So 1 plus delta x times I. I is, delta x is 1/3. 1/3 I. This is x of I. So f of x sub I is 1/3 of I plus 3 squared. Sigma notation from summation from I equals 1 to n, that is 12, of 1/3 I plus 3 squared times delta x times 1/3. Now this is the same as now with this notation. Here x sub I is now this a, that is 1, plus delta x times I plus 1. Delta x is 1/3. 1/3. So is I is 1/3 of I plus 1 and 1/3, this is 3/3, 4/3. So f of x sub I will be 1/3 of I plus, this is 6/3, 10/3, 10/3 square. So this is the summation from I equals 1 to from I equals 0 to n minus 1, so to 11, of 1/3 I plus 10/3 square times 1/3. This was the right Riemann sum expression. Now let's do the left Riemann summation for this in order to compare them. Alright, so let me erase this. Alright, so for the left one, we have, we erase it and then we write them again if we need to write them again. And also it helps for practice to write them all the time. Let me turn on the light. Alright, now the left Riemann summation was from I equals 0 to n minus 1 of f of x sub I delta x. This is the same as summation notation from I equals 0 to n minus 1 of f of x sub I is when we go from I equals 0 to n minus 1 is a plus delta x times I, and then all these times delta x. The other way is sigma notation is summation from I equals 0 to n minus 1. N minus 1 is, from I equals 1 to n of f of x sub I minus 1 delta x. This is the same as summation from I equals 1 to n of f of a plus delta x times I minus 1 delta x. Alright, so for this notation, our x sub I is a is 1 plus delta x, that is 1/3 of I. So this is that is like that. And now f of x sub I is 1/3 of I plus 3 square. And so sigma notation would be from I equals 0 to n minus 1 is 11 of 1/3 plus 3 square times 1/3. And as you can see, this notation is has the same as this one, just that for the left, these are the traditional one. The traditional one from the right is from I equals 1 to, I didn't put here, to 12. And the traditional way from the left Riemann sum is from I equals 0 to n equals 11. And we have of 1/3 I plus 3 squared times 1/3. So it's kind of the same, just that for the left Riemann sum, you begin from I equals 0 to 11, and from the right Riemann sum, you begin from I equals 1 to 12. And we already know this because we compared the equations in the previous video. So, knowing the right summation equation, we can derive the left Riemann sum, and that we will do it in this one. Here, continuing with the other notation, was x sub I equals, now with this formula, is 1 plus delta x is 1/3 of I minus 1. So it's 1/3 of, just 1/3 of I. So f of x is 1/3 of I square, or 1/9 I square. But let's do it here in order to do the comparison. So is is summation from I equals 1 to 12 of 1/3 I squared times 1/3. So that is because here we reduced a or from here we reduced the subscript to 1 less. Here in the formula says I minus 1. So for that we now have this. Yeah. Oh, sorry. It's 1/3 of I. 1/3 of I plus 2 square. 1/3 of I plus 2 square times 1/3. Alright. So this was the non-traditional way to write them, or the non-conventional ways. Alright, now for the midpoint. In the midpoint, wait a second. For the midpoint, in this one, remember our f of x, or this summation from I equals 0 to n minus 1 of f of x sub I am delta x. F of x sub I is, I will do it on here because I'm running out of space, of f of a plus delta x times I plus 0.5 times delta x. Or the other is summation from I equals 1 to n of f of a plus delta x times I minus 0.5 delta x. Alright, so now our x sub I is 1 plus 1/3 times I plus 0.5. So it's 1/3 of I plus 1/6. So f of x sub I is 1/3 of I plus 12/6, 13/6 square. So we have summation from I equals 0 to 12 minus 1, 11, of 1/3 I plus 13/6 square times 1/3. The other way is summation from I equals 1 to 12 of, here now we would do x of I equals 1 plus 1/3 of I minus 0.5, so minus 1/6, and so plus 11/6. So it's 1/3 I plus 11/6 all square times 1/3. So here we reduce just 1 delta x. Alright, now this was for the midpoint, this was for the left, and this was for the right Riemann sum. Alright, in the next video we're going to do this example. We're running out of time.